Hey everybody, this is Larry, this is me with Q3 of the Bi-Weekly Contest 127, shortest subarray with or at least K2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem and this contest, I guess, and everything in general in the comments. But the idea here is sliding windows, and or maybe you could say it, a contribution, right? We've been doing this all week. If you've been watching my daily problems, and I hope that you have, I've been kind of doing the explanation all week, and we've been doing that explanation the last 3 or 4 problems on the daily problems. But that's that sliding window. So if that makes sense, then the idea will be pretty straightforward. So one thing to know about the bitwise OR, and I talked about this in Q1, is the first thing to know about this problem is that n is too big for n squared, right? Okay, fine. I mean, otherwise this would be Q1. We already did Q1, hopefully. But yeah, so second part is that the bitwise OR operation, it is, I forget the term, there's a mathematical term for it, but basically it is greedy in a way that when you add more numbers, the value only goes up. It doesn't ever go down. So when you subtract numbers, the number only goes down, it doesn't go up. So there's this like monotonic property, monotonicity property that allows us to do sliding window in a greedy kind of way, because whenever we add numbers, we know that it will give us a bigger number, and when we subtract numbers, it will give us a smaller number, which is what we need for sliding window. With that in mind, this could be a little bit tricky if you if you don't kind of handle it correctly, but we'll go over it pretty quickly now, right? So the idea here is that with a sliding window, you add numbers and then you subtract numbers and then you figure it out in between. So here we're going to talk about contribution, and then we'll talk about the invariant, right? So the invariant for me is that left right inclusive, and here f sub I is equal to the number of times the ith bit is seen in the range, right, of left right. That's basically the idea, and the idea here is because when you add stuff, you do an OR and you get a bigger number, but when you subtract stuff, you still may have a 1 inside, right? Meaning, okay, let's just do because all the bit operations are independent of the other bits. I can show you that, like, for example, if you have 0 1 right, something like that. If this is your left and this is your right, just because you subtract 1 from the left by going incrementing it to the left, just because you subtract 1 here, but this still has 4 1s, so inside the range it still has 1s, right? So you have to keep track of them, so that when it goes to 0, then you're able to remove it, as we'll show in a second. So looping. So here we want to say here current. I'm talking about loop invariance, right? So at this particular point, current is going to be less than k. That's the invariant. We started out with current is less than k, 0 0, and f sub. Yeah, that's pretty much it, really. And f sub I has this stuff, but I think it doesn't change here or anywhere, really. So then now we process num sub right, and we process num sub right by looking at every digit, every binary digit at a time. If it has a 1 in that digit, and this is how you write it, if there's a 1 in that digit, we increment that count by 1. If it is 1, remember, this can only go from 0 to 1 in this case. That means that now we can do a bitwise OR on this. You can also do it without this check, because this is additive, right? I guess additive is the word I was looking for a while. This is additive, so it can it doesn't matter, right? If it's already a 1, it doesn't change anything. And then now after that, so after this change, after we process it, f sub I now contains the updated data. Current now contains left right inclusive, right? so current now contains the bitwise OR of everything between left and right inclusively. So then now we go, if this is the case, and actually I don't even need this if because this while statement handles it, but it doesn't matter that much. But yeah, but basically if current is greater than or equal to k, and left is, I don't know, I just have this here for breaking reasons, which we'll go over in a sec. But if current is less than k, or greater than or equal to k, then now we know that right or left to right contains k, right? Contains or bitwise or of greater than or equal to k, and so we just try to calculate the best from this, right minus left plus 1, right? That's the size, and then now we subtract this out. Now we move num sub left from the range and to try to make current smaller, right? And this is the same idea except for in reverse for this, right? If there's a bit for we process num sub left. If there's a bit here on the ith position, we subtract it by 1. Remember that with a 0, which is it goes from 1 to 0, then now we take it out by taking the inclusive. You can also, there are a couple of ways you can write this, but that's how I do it. I just flip it from 1 to 0, and then we increment left to move it to left 1. And then we just, in a while loop, we check it again, and then this should shrink until it's the smallest that contains both. Until current is less than k, but then now you terminate. So then now the invariant actually in a different is that current is less than k again, and f sub I is contains the right updated data again. Yeah, and then you loop again. So that's the loop invariant. So this is the loop invariant, and this is kind of the loop invariant as well. So yeah. And then at the end, of course, if we have too many things, we return -1. Otherwise, we just return the best item. So what's the complexity here, right? Well, make it slightly smaller so you could see most of it in one screen. Still a little bit, not so much, but all right, let me just take out this. You got this, right? So this is everything on one screen. It's a little bit smaller. But yeah, so what do we have here, right? What's the complexity? Well, F is going to be O of alpha, where B maybe is for number of bytes, or number of bits specifically, but the order of number of bytes, which is O of B. And here, this is going to be O of N, this is O of B, right? So this loop, remember, we call it the same thing that we've talked about all week in the daily problems. Left can only increment n times, so this loop can only happen n times in total. And each of the n times we do O of B work. So this is going to be O of N plus, or O of N times B, sorry. Times and O of B space, right? And remember, record that B is equal to the number of bits, which is 32 in this. Or I guess technically 30 because, 10 to the 9 is 30, but I just do 32 just in case. I don't know. But yeah, and that's pretty much all I have for this one. Let me know what you think. The idea, I think the tricky part about this one is that I think the sliding window idea, especially if you've been practicing the last couple of days, is pretty straightforward. But you have to figure out how to add, which is what we have here, which is maybe easy because you don't need this if statement. You can just do this and you'll be mostly, like you could do the current or you go to the num sub right and you'll be right. But the tricky part is that you have to process this in a way such that you can do the removal in a clean way. And that's the tricky part about this one. And for this one, for the removal, it is important to kind of go over the edge cases and just thinking about, when you do bitwise OR, you can do every bit independently, right? So that's basically the idea. All right, that's all I have for this one. Let me know what you think, and you could watch me solve it live in the contest next, but keeping in mind that the live portion kind of jumps around a little bit because the server was having issues, so I was jumping around literally. So if you want to watch the entire contest, I have a different video for that, so check that out instead. And yeah, that's all I have. Watch me next. Thank you. Alright, let's just skip ahead, I guess. We already know what the thing is with this one. Right. We'll bring this back up. Yeah. Well, this is a better way to do it, but this is our way to do it. I don't know if this is the best way to do it. I don't think I'm doing that poorly, to be honest. This one's wrong. Okay, I have to go back to look for it. Oh, this is the picture. Okay. I got distracted by something. I knew about this, but what a silly mistake. That one. This contest is pretty poorly though, but yeah, it's greater than or equal to. I guess I could give submit. Maybe I get it wrong anyway. This contest is kind of annoying, so we'll see. Oh, it's just chaos because I wanted to test this actually, but then I just forgot. It really messed with my flow, and I didn't even sleep enough. But I could tweak this a little bit differently, but I think I'm just gonna keep it lazy for now, and then we'll see if this is fast enough. Silly mistakes, but the contest is just a mess. Everything is pending. Everything is chaos. And I have all 5 ones all up the wazoo. Maybe I guess I'll have to Q4 and kind of make up time, but we will see. All right, mod. Mod. Can't even see anything. Okay. Nums n and a positive integer k. Minimum absolute difference between any 2 elements. Minimum absolute difference between 2. Was n? N is 50, huh? What does that even mean? Which have length is equal to k. Okay, so length is k. If 50 choose k. Okay. It's going to be dynamic programming probably. The minimum absolute difference. So that means it's going to be 2 times. Okay. 131. Just checking, but alright. Is it DP? Yeah, this is disaster. Ooh, this is wrong answer. Okay, let me debug this real quick. Oh, I don't update this. Oh no, I click on one code and it's gonna take a while. I'm still gonna work on it, but I hope that they don't that they cancel this because I'm doing terribly, to be honest. But also, like, it is legitimately, you know, just chaos, right? Like, I can't even one code. This is, I don't know. Let's see if I can figure this one out. How do I do this? Oh, I think this is right. It actually finished running, but I didn't realize. Oh, whatever. I'm so distracted. How do I start this? Okay, let's just click on submit. Alright, so that's good. That means that I should be able to submit this part. Oh, there we go. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Hope you have a great weekend and holiday. Yeah. Let me know what you think about this problem, this contest, and all the service issues and all these things that you may run into. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.